Thousands of airplanes fly across the world every day, carrying millions of passengers through the skies. But have you ever stopped to wonder how a massive machine weighing hundreds of tons can lift off the ground and travel through the air? The answer lies in the fundamental principles of physics and engineering that have been perfected over more than a century of aviation history. Flight is a balance between four essential forces that work together in perfect harmony. When lift becomes greater than weight, the airplane rises into the sky. Thrust pushes the aircraft forward through the air, while drag tries to slow it down. Understanding these forces is the key to understanding how flight is possible and how engineers have mastered the art of defying gravity. The secret to flight lies in the wing, one of the most brilliantly designed structures in engineering. An airplane wing is not flat. It has a special curved shape called an airfoil. As the aircraft moves forward, air flows both over and under the wing, but at different speeds. The curved upper surface forces air to travel faster, while air beneath moves slower. According to Bernoulli's principle, faster-moving air creates lower pressure. This pressure difference generates an upward force called lift. The wing's angle of attack, the angle at which it meets oncoming air, also plays a crucial role. During takeoff and landing, pilots extend flaps to increase the wing's surface area and curve, generating more lift at lower speeds. This elegant design allows hundreds of tons of metal to float effortlessly through the sky. Thrust, the force that propels an airplane forward, comes from powerful jet engines mounted beneath the wings. Inside a modern turbofan engine, air enters through the massive front intake at incredible speeds. Giant spinning blades compress this air, increasing its pressure and temperature dramatically. In the combustion chamber, fuel is injected and ignited, creating an explosive reaction that heats the compressed air to over 1,000 degrees. These superheated gases expand rapidly and blast out the back of the engine at tremendous velocity, producing the thrust that pushes the aircraft forward. The faster the aircraft moves, the more air flows over the wings, generating the lift needed for flight. It's a beautiful symphony of thermodynamics and aerodynamics working together in perfect precision to achieve what once seemed impossible. From the moment an aircraft begins its takeoff roll to the instant its wheels touch down on the runway, every phase of flight is a carefully orchestrated demonstration of aerodynamic principles. As the engines roar to full power, thrust accelerates the airplane down the runway, while the wings begin generating lift. When airspeed reaches the critical point, the pilot gently pulls back on the controls, increasing the angle of attack, and the nose lifts skyward. Once airborne, the aircraft climbs steadily, wings slicing through the air with precision. At cruising altitude, all four forces achieve perfect equilibrium. During approach and landing, pilots extend flaps and deploy spoilers to increase drag and control descent rate. Flying is not magic. It is the result of physics, engineering brilliance, and over a century of human innovation pushing the boundaries of what's possible.